So in this video, we're going to be looking at the last two cases of solving our auxiliary equation. So we've got when b squared minus 4ac is greater than 0. And this is a super straightforward one. We know that r1 will be equal to minus b plus the square root of b squared minus 4ac over 2a. We know that r2 is going to be equal to minus b minus the square root of b squared minus 4ac all over 2a. So then our solutions, we're going to be taking the linear combination of these linearly independent solutions. So that's going to be a times e to the r1x plus b times e to the r2x. Great, and that's it. This is our general solution, right? This is our first solution this is the first solution that we get, y1. This is our second solution, y2. A and b are just constants, so since y1 and y2, we know that they are unique and they are linearly independent solutions. So we can take the linear combination of these solutions to get the general solution of our ODE. Okay. And that's it for case 2. Super straightforward. Just use the quadratic equation. Our next case, so this is case 3, when b squared minus 4ac is equal to 0. And this one's a little more difficult, and essentially we can find one real solution, but quadratic formula kind of implies that there are two solutions and that the other solution is just hidden and more difficult for us to solve. So we know that, okay, r1 would be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we know that this would be equal to 0, so r1 is equal to minus b over 2a. Okay? So that's important. And we are looking for another linearly independent solution, right? So we know that y1 is equal to e to the r1x. To find a linearly independent solution, we can suppose that v of x, so some function times the solution that we know, y1, is going to be our other solution. Okay? So let's just rewrite this. We'll call this v times e to the rx. Okay? Good. So let's plug this back into our auxiliary equation. So we've got a times, and I guess first we're going to have to take the derivative and our second derivative of y2. So y2, this will be v prime times e to the rx plus r e to the rx times v. And then y2 double prime, we're going to have to do some more chain and product rule. This is going to be v double prime e to the rx plus r e to the rx times v prime plus r squared e to the rx times v plus v prime times r e to the rx. Great. This can also be simplified a little bit more to v double prime e to the rx plus v prime times 2 times r e to the rx plus r squared e to the rx times v. Great. Okay, so now let's substitute y2 back into our auxiliary equation and verify that this is a solution. Okay, so we know a times, this will be v double prime e to the rx plus v prime 2r e to the rx plus r squared e to the rx v plus v, or b, times, and this is going to be v prime e to the rx plus r e to the rx times v, and then plus c times v e to the rx, and this all equals 0. Okay, great. So what we can do here, you'll notice we've got an e to the rx in all of our terms here, right? So we can factor out e to the rx. We know that that's never going to equal 0. So essentially we can kind of ignore it, or you can think of it as canceling out, but just know that we're really just factoring it out. So to simplify this, we're going to get a times v double prime plus a times v prime times 2r plus a r squared times v plus b v prime plus b r times b times r times v plus c times v, and this equals 0. Okay, and we can simplify this a little bit more, and we're going to get a v double prime plus, let's factor out our v prime, and this gives us a times 2r plus b plus, and then v times a r squared plus br plus c equals 0. Great. So we have this, and you'll notice that this is our auxiliary equation, right? This is our auxiliary equation, right? And this is R1, right? This R that we have is R1, and if it's R1, then we know that it's going to equal 0, right? Because it's the auxiliary equation. So if this equals 0, then let's take a look at our second term here. We have this right here. Let's simplify this. We have r is equal to minus b over 2a. And remember, that's important. We already talked about this. Look, if r is equal to minus b over 2a, then if we were to substitute that into this term, we're going to find that that is going to equal 0. So this term also equals 0. Okay? So we need this, we want this auxiliary equation to equal 0. So our second solution is right. So let's solve a v prime prime equals 0, right? And we can so easily do this, guys. It's literally a second derivative is equal to 0. We know that our first function is going to be in the form, let's call it a x prime plus b x, right? This has got to be equal to 0. Okay, just to confirm that this makes sense, right? If we take the derivative of this, we're going to get a x. Oh wait, hold on, this doesn't make sense. Sorry guys, correction, that didn't make sense. So what we've got here, we've got v double prime equals 0. So this implies here that this is going to be equal to some constant, let's call it a, right? We take the derivative of that, we're going to have that equal 0. So that means that v is going to be in the form of ax plus b, right? This is just simple. You could do this separation of variables if you want. It's a little bit overkill because you can sort of just think about this, right? You can easily verify that if we take the second derivative of this v, it will be 0, right? And what we can actually do here is we can drop the a and the b because we're taking the linear combination of the solution in this next step. So and that'll make sense in just a little bit. So if we got v is equal to x, right, then this means that y2 would be equal to, and remember we said that y2 is vx times y1, right? So y2 is equal to x times e to the r x. Great. So now, in this super easy simplified form, we're going to be taking the linear combination of our two solutions, and that's why it's okay to just drop these a and b, right? So our general form of the solution is going to be y is equal to y, and let's call this c y1 plus d y2. So this is going to be y is equal to c times e to the r x plus d times x e to the r x. And this here is what you're going to jump to when you only have one solution and you're using an auxiliary equation to solve your ODE.